So hello guys, me Ankur Bansal, and here we are discussing the previous year's GATE papers. The subject that I'm discussing is Instrumentation and Process Control, and already we have discussed the two papers of GATE 2020, 2020, GATE 2020 and GATE 2019. So 2020 and 2019 already I have discussed, okay, and today I will gonna discuss the paper of GATE 2018. So very good afternoon to all of you, and before discussing, let me tell you something how to connect with me. So guys, there is a Telegram group with the name t.me/Ankur073. If you search on the Telegram with the name Ankur073, you will find my channel. The name of the channel is Chemical Engineering with Ankur sir. So you can join this channel, and I will share all the update of my live classes, paid as well as free, on the YouTube as well as on the Unacademy. I will post all the updates and all the updates about the GATE, all the updates about the jobs and everything. I post it on this group. So you can join this channel to connect with me. Okay. Apart from that, you can search me on the Unacademy app. My name is Ankur Bansal. So you can search me on Unacademy app and can follow me there. Then you will get the notification every time when I go live. You will get a text notification about all my classes. Okay, so this is the information, and guys, the new Accelerate batch has already started from Sunday. From this Sunday it has already started. Today is the third day, so still you can catch up guys. In the 3 months time, we're gonna cover the complete syllabus along with the previous year's questions and along with the practice questions. And guys, there is an announcement that 1500 plus practice questions will be provided to you, that is having the GATE questions quality. So the questions that we will provide you on the Unacademy platform, all of them are of the GATE level or above. So many students tell me or ask me, sir, from where to do practice, from where to do practice. So guys, we are providing you the practice sessions now, and this is also included in the Accelerate batch. Okay. So in the 3 months, we'll cover the whole syllabus, we'll cover the PYQs, and as well as we'll provide you the 1500 practice questions with the solutions. So you can practice that, your GATE exam, and ultimately you get a very, very good rank. Okay. So guys, let us start the 2018 paper, and this is the first question. So that is the first question. Okay. So what you need to do is to solve this. Okay, I am giving you 1 minute or 2 minutes to solve, and then I will tell you the solution of this question. Okay, if you are live, watching me live, then don't message the answer. Okay, don't write ABCD. Okay, don't message the answer. Just write done if it's done. And those who are watching the recording, okay, they can solve on their notebook. Okay guys, so let me discuss this question now. So in this question, as you can see, that the first order process is having the transfer function Gp is equals to 2 by 7s plus 1. It is controlled by the proportional controller with a gain of 3.2. The process time constant is given in minutes. Addition of the integral action with an integral time constant of 5 minutes leads to an increase in. So it's a very simple question that a first order process is being controlled with the proportional action. Now what happens if I add the I action with it? So if I add the I action with it, there has to be some change. Those who don't know about the I action, okay, let me tell you that for the PI action, the transfer function look like this, Kc into 1 upon 1 plus tau is. This is the transfer function. So that means when a PI action, when a PI action is in series with a first order system, then both of them combined becomes a second order system, because you can see there is S in the denominator. So S in the denominator means what? It is having a first order kinetics. So PI action is having a first order kinetics, and if it is connected with a first order system, then the overall kinetics of the diagram, overall kinetics of the system will be 2. So guys, is there any increase in the order of the closed loop system? Order of the closed loop system, yes. The order of the closed loop system get increased. Okay, why? Because PI action has a first order kinetics, first order has a first order kinetics, and if I combine the both, then both will have a second order kinetics. So order of the closed loop system will increase. Now we also know that the second order system are slower than first order system. Second order systems are slower than first order systems. I hope you know it, because the lag of first order system is tangent inverse minus omega tau p, while the lag of second order system will be 2 times tangent inverse of minus omega tau p. So lag is just more, guys. So as lag increases, the system becomes slow. So what happens to the speed of response? Speed of response increases or decreases? Obviously decreases. So it cannot be the answer. So as the system order increases, the speed of the response decreases. Okay. Now if we talk about offset, guys, then for the P action, offset is 0. Offset is not 0, non-zero. Okay. For the PI action, offset is 0. So that means what? That means addition of I action reduces the offset to 0. And guys, those who don't know about the offset, let me tell you what is offset. Offset is the value of the set point at the infinite time minus the value of the response at the infinite time. That means YSP infinite minus Y bar infinite. So this is the set point and this is the response. So value of the infinite value of the set point to the infinite value of response. Or in short, I can say it is the steady state error. It is also known as steady state error. This is the value that is desired, guys, and this is the value that you control. So when your controlled value, your controlled variable becomes equal to the desired variable, then offset will become 0. And ideally what you don't want any offset. You want your offset to be 0. In life also what we want, that whatever we want, we should have it. Our offset will be 0. If you want a BMW and you are having a BMW, your offset is 0. But if you want BMW and you are having some other car, okay, then your offset is non-zero. So in the case of P action, your offset is non-zero, but in the case of PI action, your offset is 0. So addition of I action reduces the offset or increases the offset? It actually reduces the offset. So what happens to the option number 1? Offset increases or decreases? Decreases. So that cannot be the answer also. And talking about the proportional band, guys, this is the value of the system. This is the value of the transfer function. Okay. But if I write it in terms of the output input, then C bar S divided by E bar S is equals to Kc into 1 plus 1 upon tau Is. Okay. So that is the transfer function. Now this range is known as the proportional band. Okay. This is known as proportional band. So guys, ideally when Kc increases, proportional band decreases. But here we have added the I action. So there will be no change in the proportional band. For the same range, the PI action can be added. Okay, that there is a band in the case of P action. Let me tell you in a different slide. Okay, so first of all, you are having a P action. First of all, you are having a P action with a gain of Kc. Then you are having a PI action with a gain of Kc. Kc for the PI and Kc for the P. For the case of P, what is your output? For the case of P, your output is Kc into E bar S. But for the case of PI, your output is Kc into E bar S plus Kc by tau I into 0 to T it is in the time domain, so this is ES. So in the time domain I will write it. I don't have the eraser option here actually. So C bar S is equals to Kc into E bar S plus Kc by tau Is. Okay, into E bar S. So guys, this is your P action and this is your PI action. Here this is a value of Kc which is a fixed value. In the question it is given as 3.2. So for that fixed value of 3.2, there is a fixed value of the proportional band. So what I did now, keeping the value of proportional band same, means the proportional band of the P and the proportional band of the PI I kept same. What is proportional band? Proportional band is the range of the input over which the controller can perform the output. Controller can take a decision. It is a range of the input. Okay. So what is E bar S? It is a range of the input or range of the error signal. So this is the range of the error signal. So keeping the range of the error signal fixed, you have added the I action. So obviously if ES is fixed, then this plus this will become more. Output will be more. So to balance out what we do, we keep Kc little less. So generally the Kc for the case of Pi is actually less than the Kc for the case of P. But it doesn't mean that there is a change in the proportional band also. Proportional band often remains the same. So by adding the I action, Kc actually decreases. Okay, and proportional band is inversely proportional to Kc. So it may look like that the proportional band should increase, but no. Generally in the designing, the proportional band is kept same, and just we add the action. By adding the action, what is the effect? Effect is on the Kc only. So Kc either increases or Kc decreases. Output either increases or output decreases. But generally the range of the input, the range of the error, the proportional band remains the same. So that is what we do in the designing. By not changing the proportional band, what we do? We change the value of Kc. Okay. And one of you is asking, Arun, that what about the D action? Sure. So when you add the D action, EID, the transfer function will be Kc into 1 plus 1 upon tau is plus tau ds. So this is the D action, guys. This is the D action. Okay. Only for the D action. GC for the D action is Kc tau d s. This is only for the D action. So if you calculate of the PD, let's say there is a transfer function. If you take this question only, and there is a PD action, so we'll tell you the offset in this case so that it will be clear to you. So for this question, let us calculate the offset for P. Okay. So for what is the overall transfer function? Overall transfer function will be 3.2 into 7 by 2s plus 1. No, 7 by 2s plus 1 is 2 by 7s plus 1. So the question is actually reverse. GS is equals to 3.2 into 2 by 7s plus 1 divided by 1 plus 3.2 into 2 by 7s plus 1. And this is what? This is y bar s divided by ysps. So if you provide the unit step change in the set point and then apply the final value theorem, then the value of y bar infinite will come out to be, just put s as 0 here, you get the answer. So 2 2s are 4, 2 3s are 6 divided by 6.4 plus 1, that is 7.4. So 64 by 74 is the value of y infinite. And what is the value of ysp? Ysp value will remain 1 because you have provided a unit step change. So what is the offset? Offset will be 1 minus 64 by 74. That is the value of the offset. That is non-zero. So for the P action, the offset is non-zero. Now let us calculate for PD. Okay. So for PD, let's say Kc remains same and tau d is, let's say, 1. So the tau d value I am taking 1 and Kc value I am taking same for the simplicity. So what will be the overall transfer function in that case? It will be 3.2 into 1 plus s into 2 by 7s plus 1 divided by 1 plus 3.2 into 1 plus s into 2 by 7s plus 1. So again that is equals to y bar s divided by ysps. And if you take the unit step change and apply the final value theorem, the value of y bar infinity comes out to be, again you just put s as 0 and what you get? It's 6.4 divided by 7.4. You get the same, guys. There is no change, and that means offset remains the same. And that is a mathematical demonstration that I've given you. So by adding the I action, the offset reduces to 0, but D action doesn't affect the offset. It just fastens the system, it reduces the oscillation, but it doesn't affect the offset. Okay, so that is the answer of your question, Arun. So I hope now this question is clear to all. So the answer is increase in the order of the system by 1. So this is the next question, guys. This is the next question. So again I'm giving you 2 minutes. You can solve and then I will tell you the answer. Okay guys, so let me tell you the answer. So the question is, we have to calculate the decay ratio and the poles of the system are being given. So there are two poles, so I can say the order will be second, because for the second order system there are generally two poles, and according to our syllabus we define the decay ratio also for the second order system. So I can assume that this is second order system, and for the second order system the complex conjugate poles are given. So first of all you should know that for the second order system, what is the transfer function? The transfer function is Kp divided by tau square s square plus 2 zeta tau s plus 1. And if you put this denominator equals to 0, then the value of s that you get is minus zeta by tau plus minus under root of, if zeta is less than 1, then obviously you get 1 minus zeta square. If zeta is greater than 1, you get zeta square minus 1. So that depends. Okay. So this is the roots that we get, minus zeta by tau plus minus under root 1 minus zeta square by tau. And yes, there is iota also, because I have calculated only for the complex conjugate poles. So for the case of complex conjugate poles, this is the value of S, complex conjugate poles. Okay, so if I compare this with the poles given in this question, so minus 1 by 10, minus 1 by 10. So minus 1 by 10 must be the value of zeta by tau. So zeta by tau must be equals to 1 by 10. And under root of 1 minus zeta square by tau must be equals to 2 by 15. Under root of 1 minus zeta square by tau must be equals to 2 by 15. So let us calculate tau from here. So tau will be 10 zeta. So put 10 zeta here. What I get? Under root of 1 minus zeta square by zeta. 10 zeta. So that will be 20 by 15 or 4 by 3. So what I can do now, I can square it if I want to solve. So it is 1 minus zeta square is equals to 16 by 9 into zeta square, or 16 by 9 zeta square plus zeta square is equals to 1. The zeta square comes on this side, gets plused. So 16 by 9 plus 1, it's 25 by 9. Okay. So it is 25 by 9, zeta square is equals to 1, or zeta is equals to 1 by, not 1 by, it's 9 by 25, and ultimately zeta is equals to 3 by 5. The negative value is rejected because zeta is a physical parameter, so it cannot be negative. So the zeta comes out to be 3 by 5. So by comparing the poles given in the question with the poles of the second order system that we know, the zeta can be calculated. And once the zeta is known, the decay ratio can be calculated, because the formula of decay ratio is exponential of minus 2 pi zeta over under root of 1 minus zeta square. Okay, that is the value. So exponential of minus 2 pi zeta, which is 3 by 5, divided by under root of 1 minus zeta square, which is 9 by 25. So by solving this, you can have the answer. Minus 2 pi into 3 by 5 divided by 4 by 5. 5 and 5 cancels, 2 and 4 cancels. It's minus 3 pi by 2 or minus 1.5 pi. So that is a simple thing. Now we can calculate that and we can have the answer. So the answer comes out to be 9 into 10 to the power minus 3. That is the value of decay ratio that you will get. Okay. So I hope guys you are getting the same result. Now moving on to the question number 3 of GATE 2018. This question, guys. So again, take 2 minutes and then I will discuss what is the answer. Guys, after this session, tomorrow also there is a session in which I will discuss the GATE 2017 paper. ठीक है? Tomorrow, that means Wednesday. Tomorrow is Wednesday. So tomorrow Wednesday, again the same time, 12 p.m. I will discuss the GATE 2017 paper. And then on Friday, this is on Wednesday, that is tomorrow, and then on Friday, again on 12 p.m. I will discuss the GATE 2016 paper of IPC. So today is GATE 2018, tomorrow is GATE 2017, and on Friday GATE 2016. So be there with your friends so that we can finish it live. बिकॉज लाइव में जो अंडरस्टैंडिंग होती है वो ओब्वियसली रिकॉर्डिंग में आप खुद से कर रहे हो, बट लाइव में यू आर ऑल्सो communicating with the faculty, so that is much more beneficial. Okay, so talking about this question, guys, we have to compare, match the column it is. So we should know something about these 4 things. Like for the dead time, what you should know? For dead time, you should know the transfer function. What is the transfer function of dead time? E to the power minus TDS, where TD is dead time. TD क्या होता है इसमें? Dead time होता है. ठीक है? What is the amplitude ratio of the dead time? Amplitude ratio is 1. What is the phase angle of the dead time? Phase angle is minus TD omega into 180 by pi in degrees. That is the phase angle of the dead time. So you should know the transfer function, you should know the amplitude ratio, you should know the phase angle. ठीक है? So for the pure dead time, phi is minus 90 degree? No, because phi is minus TD omega into 180 by pi. This is the transfer function? No, the transfer function is e to the power minus TDS. क्या amplitude ratio 0 to 1 के बीच में रहता है? No, the amplitude ratio for the dead time is 1. Amplitude ratio is 1. So this is the correct thing. Amplitude ratio is 1. So for P, 4. Now before going to Q, just match the option first, P to 4. So P2 wrong है, P3 wrong है, P1 wrong है, P4 correct. So correct guys, and when it is correct ना, no need to go for other options in GATE. अगर पहले ऑप्शन से आपका आंसर आ गया, save the time, move forward to the next question. Don't waste your time in doing another options also. ठीक है, या तो हम बाकी तीनों के बारे में पढ़ेंगे, but for the GATE I'm telling that once you got the answer, just move on. ठीक है, pure capacitive system. Now for the pure capacitive system, what you should know? For the pure capacitive system, what you should know? You should know GS is equals to the transfer function. What is the transfer function? It is Kp by S. That is the transfer function of pure capacitive system. What is the amplitude ratio? Amplitude ratio is Kp by omega. So as omega increases, amplitude ratio decreases. And what is the phi? Phi for the purely capacitive system is 90 degree. So these are the three things that you should know for the purely capacitive system. So you can see phi is 90 degrees written here, and that is pure capacitive system. So Q must be 1. ठीक है? Now inverse response. So guys, what you should know about the inverse response? For the inverse response, the transfer function is given as Kp1 divided by 1 plus tau P1s minus Kp2 divided by 1 plus tau P2s when two first order systems are in series. So you should know that tau P1 by tau P2 must be greater than Kp1 by Kp2 must be greater than 1. This is the point that you should know when first order is in series with the first order. The second point you should know is it shows a positive 0. It exhibits लिखो या shows लिखो, it exhibits a positive 0. Positive 0 means when the numerator of the transfer function put it equals to 0, then the value of s that we obtained is known as the 0 of the transfer function. So those who don't know, let me write for them. The roots or values of s obtained by substituting the roots or values of s obtained by substituting the numerator equals to 0, and rather than substituting I should write equating the numerator to 0 are known as zeros of transfer function. ट्रांसफर फंक्शन के न्यूमरेटर को 0 पुट करने के बाद जो इसकी वैल्यूज आती है उन्हें हम बोलते हैं zeros of transfer function. So inverse response should have a positive 0. Okay, but if the inverse response is between a purely capacitive system and a first order system, then condition will remain same, but here because tau is not defined for the purely capacitive system, so I can take 1. So 1 by tau p, if I write tau p, then tau p is greater than Kp1 by Kp2. In that case, this is the condition for the inverse response. ठीक है, if the tau p is not present and purely capacitive system is there. So guys, you can check here, this is the transfer function, you can see, and ultimately you can see here that if I take tau on that side and take K2 on this side, this can be written as 1 by tau greater than K1 by K2. So that is the condition that I told to you. So yes, that is what, that is inverse response. So for R it is 2. For R it is 2. Then for S, first order process with unit gain. Obviously you know that for the first order process the amplitude ratio is less than 1, and that is why the first order systems are called as attenuated system. Attenuated systems, इसलिए उन्हें attenuated systems बोला जाता है because first order systems has a value of gain between 0 to 1. So I discussed all the 4 points with you guys. So yes, the correct option is D. Okay, next question guys. Again take 1-2 minutes and then I will solve this. Okay, so let me discuss guys. So this is the transfer function 3 by 5s plus 1 whole square. So that is the transfer function, and they are asking calculate the amplitude ratio for a frequency of 0.5. So it's a very simple question. Just you should know how to calculate the amplitude ratio. So just write the transfer function like this: 3 into 1 upon 5s plus 1 whole square. So 3 is a different thing and 1 by 5s plus 1 is a different thing. So amplitude ratio will be, it can be treated as the gain. So gain will come as it is into 1 by 5s plus 1. It's a first order system. Okay, so for the first order system it is 1 plus 5 omega whole square. That is for the first order system, and because it is 2 times, so ultimately gets squared. So what is the value that I get? 3 by 1 plus 5 omega whole square. The square compensated the root and I get this. Okay, so what is omega? Omega is given as 0.5, so you can calculate AR. So if it is 0.5, 3 by 0.5, that is 1 by 2. और 5 by 2 it's 2.5, 2.5 square it's 0.625 because 2.5 into 2.5 it's 625 and it's 6.25 actually. So 6.25 plus 1 it is 7.25 or ultimately 300 by 725. So 12 by 25 and upon dividing you can get the answer. So the answer comes out to be 0.41. So you can get 0.41 by the answer. So that is your answer guys, very simple. कल के टेस्ट में 19.9 आंसर आ रहा था, वो क्वेश्चन एक बार देख लीजिएगा। राज अब 19.91 किसका आंसर आ रहा था तुम एक बार ग्रुप पे डाल देना, ठीक है। आई होप तुम्हें मेरा ग्रुप पता होगा क्या है ना। इट इज़ t.me/ankur073. if you are on this channel then you can post your query on that channel, ठीक है। और अगर तुमने पोस्ट करी है और मैंने नहीं देखी तो एक बार दोबारा डाल देना, मैं आज देख लूँगा, ठीक है। अब ऐसे नहीं पता लगेगा 19.9 किसका आंसर आ रहा था, बिकॉज आई एम प्रिपेयरिंग ए लॉट ऑफ क्वेश्चंस, है ना। वही मैंने कहा ना, अगर तुमने डाला होगा मैंने नहीं देखा एक बार दोबारा डाल देना, ठीक है। पिन इट, बाप रे इतना इम्पोर्टेंट नहीं है ये, पिन इट कर दोगे तुम चलो कर देना, ठीक है, देख लूँगा मैं। ओके नेक्स्ट क्वेश्चन गाइस, अगेन टेक 3 minutes and then we'll tell you the answer. Very good guys. So for a closed loop system, consider the following transfer functions: process transfer function, controller transfer function, measuring device transfer function, final control element transfer function. So let me take this. So we have this system. Let me make the block diagram of it. So this is the set point. This is the controller transfer function. This is the final control element transfer function. This is the process transfer function. Okay, and disturbance is there or not, you can see in the last line. Step change introduced in the set point. So the step change is introduced in the set point. It means it's a servo problem, and if it's a servo problem, no need to introduce the disturbance here. So that will be your response. And for measuring this, you have applied a measuring sensor, and you are giving the signal to the comparator with the help of this measuring sensor. Okay? So measuring sensor is given as 1, so that signal is actually Y bar. GF is given as 1. Okay, so Volt just implements the decision taken by the controller by not giving its own input. GC is 2, so that is the proportional action is given, and the process is 2 by S plus 1, 2 by 7S plus 1, so that is the first order system. So if you calculate the closed loop transfer function is 2 by 2 into 7S plus 1 divided by 1 plus 2 into 2 by 7S plus 1 into 1 for the final control element into 1 for the final control element as well as for the measurement sensor. So I hope you know the formula. It is GC, GF, GP divided by 1 plus GC, GF, GP, GM. So I am just following this formula to get the answer. And when you take the LCM, guys, you will get closed loop transfer function will be, it's 2 into 2, 4 by 7S plus 1 divided by 1 plus 4 by 7S plus 1. If you take the LCM, you get 4 by 7S plus 1 plus 4, or ultimately closed loop transfer function, that is Y bar S divided by YSPS. This is given as 4 by 7S plus 5. Now, clearly they have mentioned that the unit step change is introduced in the set point. So unit step change is introduced in the set point. So that means YSP in the time domain is 1, unit step change is introduced. That means in the S domain it will be 1 by S. So the value of Y bar S, that is response, will be 4 by 7S plus 5 into 1 by S. That is the value of response. Now after getting the response, we need to calculate the final value of the response by using the final value theorem. So final value theorem is limit S tends to 0 S YS. That is, we need to check, and that is equals to Y infinite. So limit S tends to 0 S YS. What is YS? YS is this, 4 by S 7S plus 5 into 1 by S. 4 by 7S plus 5 into 1 by S. So S and N get cancelled. You put S as 0, you put s as 0 here and you get 4 by 5. So the value of y at time t is infinite is 4 by 5. And guys, what is YSP? It is 1. So at the infinite time also it is 1. Okay. So what is the difference between them? It is offset. The difference between them is known as offset. That is YSP infinite minus y bar infinite. That is the difference, which is 1 minus 4 by 5 comes out to be 1 by 5. And that is 0.2. So answer of this question is 0.2. Okay. So that is how we can deal with the questions. Already in the first question मैंने एक ऑफसेट का क्वेश्चन करवाई दिया था आपको, ठीक है. So these are the questions that came in GATE 2018, ठीक है. और कल हम डिस्कस करेंगे ऑफ द पेपर GATE 2017, ठीक है. सो अगेन जाते जाते गाइस, this Saturday I have a special class, that is conceptual marathon session. So I need maximum participations of you. Okay, conceptual marathon session on NPSH, net positive suction head. This Saturday I will gonna take the class on the conceptual marathon session on NPSH. ठीक है. So must attend that. It is very very important, very very important. Okay, the timing will be from 9 a.m. to 11 a.m. and I hope lot of your concepts will get cleared. And already I told you that on Wednesday and on Friday there are my 2 YouTube sessions on 12 p.m. on the same channel. ये जो चैनल है guys, इस चैनल को सब्सक्राइब कर लो so that आपको रेगुलर नोटिफिकेशंस मिलती रहे, ठीक है. So on 12 p.m. there will be class of GATE 2017 PYQ of IPC, and then there will be class of GATE 2016 PYQ of IPC, ठीक है. So be there live, and after that, after the complete discussion of the first 5-year papers, I will discuss the another 5-year paper, but not of IPC but of some different subject. So I'll tell you the schedule of that different subject. Maybe it's mass transfer, maybe it's mechanical operation, or maybe any other, ठीक है. So I will give you the schedule of the my next 5 YouTube sessions, ठीक है. वो schedule मैं आपको दे दूँगा और पहले से आपको एडवांस में बता दूंगा, सो दैट आप लोगों को पता रहे कि यूट्यूब पे प्रीवियस क्वेश्चन के लाइव सेशंस कब कब होने वाले हैं, ठीक है. दैट इज़ वेरी वेरी इंपॉर्टेंट. सो यू कैन लॉग इन फॉर दैट ऑल्सो. ओके, सो थैंक यू गाइस, थैंक यू. एंड कल मिलते हैं फिर गेट 2017 PYQ के सेशन के लिए राइट एट 12 PM, 12 बजे मिलते हैं, ठीक है. सो थैंक यू अगेन and we'll see you tomorrow. Take care.